Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over how to do a hypothesis test when we're comparing against a mu, or a population mean. So let's just get right into the example. We have the superintendent of a school district claims that the students attending his high school have above average IQ. A sample taken from a class of 25 students had a mean IQ of 102. If the mean population IQ is 100 with a standard deviation of 5 points, is there evidence to support the superintendent's claim? And then it says, for the purposes of this test, alpha, which is this thing, is equal to 0.05. Okay, so the first thing that I do when I see a problem like this is I just try to get every piece of information and lay it out in a way that we can plug it back into formulas later. So first, I just pick out all the numbers. So we got 25 students from our sample. So 25 in this case is our n because it's the sample size. And then it says that that sample had a mean IQ of 102, which means that our x bar is 102. Then it goes to say that the mean population IQ is 100, the mean population IQ being mu in this case, which is 100, and its standard deviation is 5. So now that we've got all the pieces that we need, we can start actually solving the problem. So the next step that we need to do is set up our hypotheses. So we need both our null hypothesis and our alternative hypothesis. So our null hypothesis for this problem will be that the student's IQ matches the population average. So in this case, we're saying that the mu is 100. And for our alternative, we want the mean of all the students to be greater than 100 because he's saying that the students have above average IQ. So our alternative will be mu is greater than 100. So now that we've got that laid out, we can start actually doing some math. So now we want to figure out the z-score for our sample. So we'll take the sample mean, the population mean, the standard deviation, and the sample size, and use them in this formula. So we've got z is equal to, it'll be x bar minus our mu over the standard deviation divided by the square root of n. So now we'll just plug in all the numbers that we know. So we have 102 minus 100 all over 5 divided by the square root of 25. So let's simplify this down a little bit. So we get 2 over 5 divided by 5, or 2 divided by 1, which is just 2. So our z-score for this sample is 2. And now this is where we can kind of break into two different methods. So the first method I'm going to show you is the p-value method. So we'll take this 2 z-score that we have, and we have to look at this table to figure out the area that's behind that line. So remember, we're looking kind of at a normal curve here. Say that z2 is right here. What this table is telling us is the amount of area behind that 2 right there. So if we look here, we're going to use this row, the 2 row, and since it's just 2, that's really 2.00. So we're looking right into this 0 column. So the 2 row, the 0 column right there. So the p-value that we're going to be using here comes from 1 minus the value we get in the table. So our p is equal to 1 minus 0.97725, which in this case is 0.2275, 0.02275, I'm sorry. Let's get that a little neater. Alright, so now we'll look at that p-value compared to the alpha value, 0.05 up here that it gave us. So we're comparing 0.05 to 0.02275, and we want our p-value to be less than the alpha value, which in this case it is. So we can reject the null hypothesis. And that's our final answer. Now I'll have to show you the other method, starting from when we got the 2 z-value. So our sample z is 2, and our alpha is 0.05. So the other method, we're going to find the z alpha, which is the z-value that corresponds to the alpha that they gave us. So first we need to figure out how much area is behind that z alpha. So first we're going to take that 0.5 or 0.05 and subtract it from 1, which gives us 0.95, and this is the amount of area that's behind our z alpha. So let's look on the table for 0.95, which it actually ends up being right between 1.64 and 1.65. So usually, in this case, we'll call z alpha 1.645. Now that we have our z and our z alpha, we're going to compare those two. So we've got 1.645 as our z alpha and 2 as our z sample. Now, in order to reject the null in this case, our z sample has to be greater than the z alpha, which it is. So, once again, we reject the null. And no matter which method you use, it should give you the same answer. So, if you want, this could be a nice little way to check to make sure you're reading the table right. Now, you'll also want to make sure that you're not confusing which one's supposed to be less than or greater than. Remember, for p-values, our p-value must be less than the alpha to reject. But with the z-value method, our z sample has to be greater than the z alpha in order to reject. And that's about it. Thank you for watching.